Greetings and welcome to part 2 of the O-Level revision series on factors and multiples. In today's episode, we'll be looking at highest common factors and lowest common multiples. The success criteria for this episode is for students to be able to find the highest common factor of 2 to 3 numbers, the lowest common multiple of 2 to 3 numbers, as well as to solve problems involving highest common factors and lowest common multiples. The highest common factor, or HCF for short, of two numbers, let's call them a and b, is the largest positive integer that divides both a and b. The HCF is also sometimes referred to as the GCD, which stands for the greatest common divisor. Let's look at some examples. Now, the HCF of 24 and 60 is 12. Why is that so? You'll see that 12 divides 24, and 12 is also a divisor of 60. And there are no numbers bigger than 12 that can do the same. What about the HCF of 17 and 31? Well, 17 is a prime number, 31 is also a prime number. Prime numbers are only divisible by 1 in itself. So the HCF of two prime numbers would be 1. So now I'm going to walk you through the steps of finding the highest common factor of two numbers using example 1. Here we want to find the HCF of two numbers 120 and 252. So the first step is to prime factorize these numbers, and we can use the ladder frame. So for 120 we can divide by 2, that gives us 60. Still divisible by 2, that gives us 30. Still divisible by 2, that gives us 15. Can't use 2, so we'll use the next prime number 3. That gives us 5. And 5 is obviously a prime number, so that would divide by 5 and give us 1. And we stop here. Same thing for 252, except that I'm going to speed this up. Then once we're done with the ladder frame, we can rewrite the two numbers as the product of their prime factors. So 120 is equals to 2 cubed times 3 times 5. 252 is equals to 2 squared times 3 squared times 7. Next, I'm also going to add the indexes for the numbers that do not have index. So here are the ones. This way I can move on to step 2. Step 2, we want to choose the lowest index of each prime factor. So you can see that 120 has a 2 cubed, 252 has a 2 square. So the lowest index is 2 square. So I'll select that one. Between 3 to the power of 1 and 3 to the power of 2, the lowest index is 3 to the power of 1. Between 5 to the power of 1 and having no 5s, well, having no 5s is lower. So I'll just select that blank space below. And between 7 to the power of 1 having no 7s, I'll choose having no 7s. So the highest common factor would be the product of what I've circled. The blanks can be considered as times 1. So what I will get for the highest common factor is 2 squared times 3 to the power of 1, and that gives me 12. Let's check the validity of this answer. Is 120 divisible by 12? Yes, it gives me 10. Is 252 divisible by 12? Yes, that gives me 21. Therefore, 12 is a divisor of both 120 and 252. And you'll see that there are no numbers bigger than 12 that does the same. Therefore, this is the right answer. In example 2, instead of finding the HCF of just two numbers, let's add a third number. Why don't you give it a try? Try finding the HCF of 120, 252, and 294. Pause the video here and give this a try before I show you the answer. So we're going to run through the two steps again. So step 1, we want to prime factorize the numbers. Well, we've already prime factorized 120 and 252 in the previous question. So now we just have to prime factorize 294. Well, we'll speed this up. 294 will give us 2 to the power of 1 times 3 to the power of 1 times 7 squared. Next, we move on to step 2. We want to choose the lowest index of each prime. And if you compare all the prime factors, that will be 2 to the power of 1, 3 to the power of 1, having no 5s and having no 7s. This tells us that the highest common factor will be 2 times 3, which gives us 6. Now it's time to check your understanding of HCF. Try checkpoint 1. Find the HCF for these 3 questions. Pause the video here and give this question a good try. And here are the answers. For part A, the HCF is 9. For part B, the HCF is 28. And for part C, the HCF is 11. Did you get the answers? And now we move on to the definition of multiples. The multiples of a number x are the products of x with another integer. For example, the multiples of 3 is 3, 6, 9, 12, 15, and so on. Similarly, the multiples of 7 are 7, 14, 21, 28, 35, and so on. But what about numbers like 0, -3, -6? Are these considered multiples of 3? Well, yes they are. These are all multiples, except they are not positive multiples. This brings us to the lowest common multiple. The lowest common multiple of two numbers, call them a and b, is the smallest positive integer that can be divided by both a and b. Let's take, for example, the LCM of 24 and 60. Well, that number is 120. We can check that 120 is divisible by 24, 120 is also divisible by 60, and there is no smaller number that can do the same. Let's take another example, the LCM of 17 and 31. Notice that 17 and 31 are both prime numbers, so the smallest possible number that can be divided by both 17 and 31 will be 17 times 31. That gives us 527. And now for example 3, I'm going to walk you through the 2 steps of finding the LCM of 2 numbers, our favorite numbers 120 and 252. Well, step 1 is exactly the same. We need to prime factorize these numbers that we've done so before. So we'll use the ladder frames. We're going to express these 2 numbers as the products of their prime factors. So exactly the same as example 1 and example 2. And when we are finding HCF, we would choose the lowest index of each prime. But now for LCM, instead of choosing the lowest index, we now want the highest index of each prime. So instead of choosing 2 square, now we're going to choose 2 cube. Instead of 3 to the power of 1, we want 3 square. Instead of choosing no 5s, we want to choose 5 to the power of 1. Instead of choosing no 7s, we're going to choose 7 to the power of 1. This gives us the LCM. The LCM would be 2 cubed times 3 square times 5 times 7. That's a total of 2,520. And we can verify this answer. Can 2,520 be divided by 120? Yes, that gives us 21. Can this number be divided by 252? Yes, that gives us 10. So this number is divisible by both numbers, 120 and 252, and you also see that there's no smaller number that can do the same. Now for example 4, we want to find the LCM of a third number. So now instead of just 120, 252, we'll add in 294 as well. Why don't you give this a try? Pause the video here and give this example a try. Well, let's go through the answer. Let's go through the 2 steps. So step 1, we want to prime factorize these numbers. We've done so for 120, 252, and earlier in example 2, I've also gone through 294. This will give us 2 to the power of 1, 3 to the power of 1, and 7 square. Then we go on to step 2. We want to select the highest index of each prime. Now, what I've circled is the lowest index. That was for HCF. But since we want the highest index, instead of 2 to the power of 1, we now want 2 cubed. Similarly, for the other 3 prime factors, we'll want 3 square, 5 to the power of 1, and 7 square. This tells us that the LCM is equals to 2 cubed times 3 square times 5 to the power of 1 times 7 square. That gives us 17,640. Moving on to checkpoint 2. Find the LCM for these following questions. Pause the video here and give these 3 questions a good try. Let's go through the answers. For part A, the LCM is 144. For part B, the answer is 5,376, and for part C, the answer is 3,780. Did you get the answers? And now we move on to solving word problems. Problem number 1. There are 3 bulbs in a room. The first bulb flashes every 90 seconds, the second bulb flashes every 126 seconds, and the third bulb flashes every 216 seconds. If they first flashed together at midnight, find the time when they next all flash together. Pause the video here and give this question a good try. So, when we're tackling word problems, it's very important to first recognize the monster that we're fighting. So I've highlighted the key points: flashes every 90 seconds, every 126 seconds, and every 216 seconds. This tells us that the bulb is flashing in multiples of 90 seconds, in multiples of 126 seconds, and multiples of 216 seconds. Then, this phrase, when they next all flash together, that must imply the lowest common multiple. So now we proceed to the 2 steps of finding LCM. First, we prime factorize the numbers. 90 is equals to 2 times 3 squared times 5. 126 is equals to 2 times 3 squared times 7. And 216 is equals to 2 cubed times 3 cubed. Now we want to find the LCM. We need to find the highest index of each prime factor. So that will be 2 cubed, 3 cubed, 5, and 7. So we multiply these 4 numbers together. That gives us a total of 7,560 seconds. We divide that by 60. That tells us it's a total of 126 minutes, which is 2 hours and 6 minutes long. So adding that to midnight, the next time that they all flash together will be 2:06 a.m. Problem 2. For his birthday party, Bob buys 324 sweets and 360 lollipops. He wants to repack the sweets and lollipops equally into goodie bags for his guests. Part A. Find the largest number of goodie bags that he can pack. And part B. Find the number of sweets and lollipops in each of the goodie bags. Pause the video here and give this question a good try. So we can start by visualizing this problem. We have 324 sweets and we want to divide them between n bags. Similarly, we have 360 lollipops and we also want to divide them between n bags. So we're looking for a number n that can divide both 324 and 360, a common divisor, and we want the largest possible one that would be the highest common factor. So let's go through the 2 steps of finding the highest common factor. Step 1, we want to prime factorize these 2 numbers. So 324 will give us 2 squared times 3 to the power 4. 360 will give us 2 cubed times 3 squared times 5. To find the HCF, we want to choose the lowest index of each prime factor. So that would be 2 squared and 3 squared and having no 5s. Multiply that together, that gives us 36. So the number of bags will be 36, and we can verify this answer. 324 can be divided by 36. Each bag would have 9 sweets. Each bag would have 10 lollipops. So by doing part B, we have also verified our answer for part A. Now before we reach the end, let's recap on the success criteria that we've set out at the start. Are you now able to find the highest common factor of 2 to 3 numbers? How about the lowest common multiple of 2 to 3 numbers? And are you now better prepared to solve word problems involving HCF and LCM? We have come to the end of part 2 on HCF and LCM. Stay tuned for part 3 where we'll be looking at squares and square roots, cubes and cube roots. Don't forget to like this video and subscribe to the channel for more math videos, and have a great day of learning.